Hello, amazing fans, and welcome to this mathematics class. In today's class, we will be looking at this question on the board, and this question concerns rational inequality. So, rational inequality is of this form. If I have, let's say for example, I have x plus 1, then let's say x minus 2, it must be of this form, either less than or equal to 0. Okay, and if you can see this question here now, this question now is not in this format. So the right hand side of every rational equation must be 0. So therefore, we have to move this one back to this, then simplify, then and make sure that what this side becomes 0. So what you do is to take this 5, your solution. Now let's take this 5. Then we now have x minus 8 all over 2 minus 2 minus x. Then take this one to this side, becomes negative 5. Then make it over 1, since this one is fraction already. Then greater than or equal to 0. Now, what is the LCM now? So this is the LCM. Okay, what we do now, here, we are going to simplify this so that we can have one single fraction on our left-hand side. So it's not possible for us to have two fractions here like this. So this one is not the normal equation we solve. So this one is different entirely. Now, the LCM of this one and this one is 2 minus x. Okay, so if this one comes here, that one remains 1, then this gives us 1 times 6. That's x minus 8. Then this one comes here, divide this, it will give you the whole of this, then multiply by 5. We have negative 5 multiplying 2 minus x, then greater than or equal to 0. Now let us open the bracket. We have x minus 8. Then 5 times 2 gives us minus 10. Plus minus 5 times negative x gives us plus 5x. Then all over 2 minus x, then greater than or equal to 0. Now let's simplify the up. We have x here, x plus 5. That gives us 6x, then minus 18, then all over 2 minus x greater than or equal to 0. So the next thing we do now is to determine the critical point. Where do we get the critical point? How do we do that? Is by setting the numerator and the denominator to 0 respectively. So if we set the numerator 6x minus 18 equal to 0, here we are going to be having 6x equal to 18. So this will now imply to us that what? X equal to 18 over 6. So x is equal to what? 3. So cancel that there. Also, let's also set the denominator. That is where we are going to be having undefined points. So if we set that denominator 2 minus x equal to 0, let's just set it now. So we just take x. This becomes x equal to 2. Now, we have this as the critical values, 3 and 2. But that's not the solution to this question. So in dealing with rational inequality, so this is just the boundary where set of values for x lie. Now, we are going to choose interval so that we can test for x less than or greater than for the both of them. So we're going to be having two intervals, and which we are going to choose now. We know that on our number line, so we have points greater than 2, points less than what? 2. Now, if we choose interval, we can decide to test and have interval where we have negative value, then before getting to 2. Okay, we can test from negative infinity for a value there that is less than 2. So any set of value that lies in this interval, we can test them by choosing any particular value, choosing one value. And we can also test another interval where we have x greater than 2 but less than 3. That is where we have 2 and 3. Then after that, we also test where x, set of points where x is greater than 3 but less than infinity. So we can have that. We'll have what? 3 and to positive infinity. So these 3 points or these 3 intervals will be tested on our number line. How do we do that? We can start to choose a value from -1. We have any number less than what? 2. We can take -1. We can even take 0. We can take -2 as the case may be. But now let us test. So first one, we test x less than 2. X less than 2. And we are going to choose a point. Take a value where x equal to 0. So let's put x equal to 0. What we are going to do now, we are going to plug this one into the original inequality here. If at the end of the day, it gives you 0. If it gives you 0, that means this point is accepted. If it gives you anything greater or anything gives you or anything less than 0, if it gives you anything less than 0, it means that point cannot be accepted. The values here cannot correspond to our solution. So let us plug that. Let's plug 0. Now let's plug 0 into the inequality. We have 6 into 0, then minus 18. Now all over 2 minus 0. So this now gives us 0 minus 18 all over 2 minus 0. So therefore, we have negative 18 all over 2. This will give us what? Negative 9. And what we need must be either 0 or greater than 0. So this point is false. It's rejected. This is false. We can't accept this. That means we can't accept x less than 2. Any point that lies here, x cannot be what? Less than 2. Now let us test for x greater than 2. X greater than 2, but less than what? 3. So which means we are going to choose any point between 2 and 3. What could be that point? We can take just 2.5. We can just say x equal to 2.5. Let us test that. So plug it into this inequality. We have 6 times 2.5, then minus 18 all over 2 minus 2.5. Now 6 times 2.5 will give you 15 minus 18 all over 2 minus 2.5 is 0.5. Then 15 minus this to give you 3 over 0.5. So this will give us negative this, negative this, negative 3 and all over negative 0.5. If you check this value here, this one and this one cancel out, automatically is greater than 0. So which means this point is what? Accepted. It's accepted. So this is true. This is true because even dividing with this is positive. So we need a positive value, and also it must be either 0 or greater than. So the last point we are going to test now is this interval. That means x greater than what? 3. Test x greater than 3. So what value are we choosing? We choose x equal to 4. Let's test it from the interval. To plug it there, we have 6 into 4, then minus 18 all over 2 minus 4. Now let us check. So this will give us 24 minus 18 all over minus 2. Okay, 24 minus 18 will give us 6 over minus 2. So minus 2 goes here, that's negative 3. So the value is negative, which means we cannot take this. This place is also false. This is for false. The only accepted point here is this point, this interval, where we have x greater than 2, but less than 3. So here we're going to take our answer. Your final answer becomes, x greater than what? 2, or x is less than or equal to 3. Now, how do we know whether it is less than or equal to or greater than or equal to? Let us check it from here. Now, if I put 2 into this original inequality, where is that inequality? We have 6x minus 18 all over 2 minus x. If I put 2 here, into this inequality, it will make the denominator to become undefined. So therefore, x cannot be exactly equal to 2. So x must be greater than 2. That's where this fraction cannot be undefined. So this point is accepted this way. Then let us go to 3. If I put 3 here into this, then numerator becomes 0. So therefore, x is less than or equal to 3. Exactly 3 if I put it here. So that is how to know whether we are to include this. So it means that 3 is included in the set of values for x. That's what happened there. Now, if I want to put this one in a bracket notation, so we're going to give us x now. That is x. We have the element of s. So this first bracket here, this 2, has to do with this. So it means 2 is not included. Then 3, we are going to use this type of brackets, this parenthesis. So this one means x is greater than 2, but less than or equal to 3. So this is how we do it. This is how we solve rational inequalities. I hope you find this solution very interesting. Please, if that is true, help us to share this post. Give me a like and also subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.